This is your review for the Chapter 2 test. So we're going to start with the foundations of logic. And that first thing we talked about was a conditional. Conditional statement is simply an if-then statement. And remember, we use the letters P and Q. P for the if part and Q for the then part. And we can refer to that as P implies Q or P leads to Q. Because if P is true, then Q is true. That's what the conditional means. So, for example, if you eat too much, you will get fat. Okay? The hypothesis is the part that's with the if you eat too much, and the conclusion is the part that's would be with the then. Now notice in this case I don't have a then, and that's okay, but I must always have the if with the hypothesis. Okay? Hypothesis, conclusion. All right? Now, once we have a conditional, we can find the converse of the conditional. Converse simply means swap. So now instead of hypothesis conclusion, I have conclusion hypothesis. So I say, if you get fat, see how I took the end and brought it at the beginning? Then you eat too much, and I put that at the end. That's the converse. Now, when we look and create these different forms, we're not worried about whether they're true or not. All we're trying to do is decide what order they go in to set up the conditional and the converse, okay? Now this is called a conditional because a condition has to take place for the second thing to occur. The condition is the if, okay? Now we have two other forms that we talked about. One is the inverse. The inverse is simply adding not to both portions. If you do not eat too much, you will not get fat. And we show that with our shorthand by this cute little mark in front of here. That means not P, then not Q. Okay, or not P leads to not Q, and all I did was in the original order put a not in there. Okay, the contrapositive is swap and put a not in. Okay, so I now have not Q leads to not P. Okay, if you do not get fat, you do not eat too much. So those are the four forms that I can put in my conditional into. The truth value of the conditional is when we decide whether yes or no, is it true or not. When we're creating these, we don't worry about whether it's true. We only evaluate if someone says, what is the truth value of this? Then you would decide yes or no. Now, the conditional and the contrapositive, the first one and the last one, will have the same truth value, whatever that is. They'll either both be true or they'll both be false. And the inverse and converse, the two in the middle, will always have the same truth value. They'll either both be true or they'll both be false. Sometimes all four of them are true because you have a conditional that happens to just be true in every form. But sometimes only the two pairs will be true. Okay, so make sure you have that in your notes that you understand what a truth value is and which forms have the same truth value. Now we take these sometimes and create a biconditional. A biconditional, bi means two. So a biconditional is a conditional that's true in frontwards and in backwards, in both directions. The original and the converse are both true. It looks like this in my shorthand. Now I have cute little arrows in both directions to show that biconditional has to be true in both directions. You'll recognize a biconditional from the words if and only if. Okay? So you will get fat if and only if you eat too much. Okay? And generally, this one that I created for you isn't true. There's many different reasons people can get fat, and there's many different reasons many different things that can happen if you eat too much. However, I just used it as an example. Normally, we're only going to make a biconditional if the statement and its converse are true. Okay? So here's a better example. An angle is a right angle if and only if it measures 90 degrees. So I can split that and evaluate and make sure they're both true. The first side might be, if an angle measures 90 degrees, then it's a right angle, and that's true. Then if I looked at the converse, it would be, if an angle is a right angle, then it measures 90 degrees. That's also true. So because this is true in the original, and it's true backwards in the converse, then I can say that this is a true biconditional. Okay? Biconditionals are often used for definitions. So the things that you're going to have to do with a biconditional is take two conditionals, take two statements, the conditional and its converse, and put them together to form the biconditional, and take a biconditional and take it apart and state what the two statements are. So you have to create it and you have to take it apart. For example, if I gave you If the angle measures 90 degrees, it's a right angle. You could write it as an angle is a right angle if and only if it measures 90 degrees. That's you creating the biconditional. And then if I gave you the biconditional, you would take it apart just like we did here and tell me what the two statements are. I'm not making up anything else. I'm simply pulling out if an angle measures 90, then it is a right angle, and then doing the converse. Okay? Sometimes students want, with this logic, they want to create all sorts of things that seem logical to them. But we're using logic in the sense that it has to follow the rules. So don't do more than you need to do with this. So as we talk about definitions, a good definition is reversible, specific, and clear. Okay? For instance, here's a definition. A fish is an animal that swims in water. Okay? The problem with this definition is, if I swapped it, I would say, if an animal swims in water, then it is a fish. That isn't true. So, this is not reversible. If it were reversible, see, what about whales? Don't they swim in water? I don't know what else there is that swims in water. People swim in water. They're not a fish. Okay, so this is a bad definition. Okay, so it's not specific and it's not reversible. But this one, supplementary angles sum to 180. So I'm thinking to myself, if an angle is supplementary, then it adds up to 180. And then I'm going to do the converse, reverse it. If two angles add up to 180, then they are supplementary. Okay, it works in both directions, so it's reversible. Is it specific? Angles adding up to 180, that's specific, and it's clear. So this is a good definition. Okay, so you notice it doesn't have an if and then in there. When we have a statement with no if and then, we add it in. If an angle is supplementary, then it sums to 180. If an animal is a fish, then it swims in water. So you're sometimes going to create that as an if-then, and that's what you'll use to find the converse to see if it's reversible. Okay? So definitions, are they good or are they bad? Logic. We talked about two kinds of logic in this section. Inductive logic is based on observation. We're looking at patterns of figures or numbers or in the world, and we're making a conjecture on what we think is going on. That's inductive reasoning. Then this chapter we talked about deductive reasoning, which is based only on the facts, not specifically our observation, not what we think is true, just on the facts. I talked about this one as relating a lot more to, let's say, a court of law, where I can only introduce evidence piece by piece by piece, and I'm not allowed to just give my observations or my opinions normally in a court of law, okay? Now, the two rules of logic that we talked about, one is the law of syllogism, and the law of syllogism is when I make a series of if-then statements, okay? And then, when I'm finished, I can put the first statement and the last statement together. So see it like this. If an animal is a cat, then it is not a dog. If it is not a dog, then it does not stay in the yard. If it does not stay in the yard, then it does not live in the country. I'm just making this up. It means I just did abbreviations for you. But what I want to point out to you is this. See how I have the conclusion of this one became the hypothesis of this one? The new conclusion here became the new hypothesis of this one. This is a chain that you have to create with the law of syllogism. If we don't create that chain by bringing it over and repeating it, then we would have to say no conclusion. But because I went if cat then dog, if dog then yard, if yard then country, I kept the chain, I can now go if cat then country. I can cut all of that out in the middle. Okay? I can put the start and the end together. Let's look at an example where I didn't do that correctly. If it's night, then you can see the stars. If it's night, then it's cold. Well, in order for this to work, I should have had stars should come over here to keep my chain. There's no chain in this one. So it may be true, it may not be true, nobody cares. The question is, can we draw the conclusion? And the answer is no. Okay, this is an example where I don't want you to think about whether these are true. I want you to think about whether I can follow from the rules of logic. Okay? And the last law that we did was called the law of detachment. In the law of detachment, you're given a statement. If it is raining, you will get wet. Okay? And then I say, it is raining. If I repeat the hypothesis, then the conclusion must be true. You will get wet. Okay? I don't want to hear, oh, but I have an umbrella. Doesn't matter. If this is true, then you conclude that this is true. Okay? If it's raining, you will get wet. It's raining. You must conclude that you will get wet. And I don't want to hear about any other reasons why you might not. We're only following what's in the words. But look at, it only works if you repeat the if portion. So sometimes I might say, if it's raining, you will get wet. Today you got wet. Well, we don't know if it was raining or not. Maybe you participated in the ice bucket challenge. Maybe you, I don't even know what, walked through the car wash out, with your windows down. I don't know why you got that. So I can't draw a conclusion if I repeat the conclusion. I can only draw a conclusion if I repeat the hypothesis. Okay? So the challenging thing about these rules of logic is you have to follow the rules of logic, not necessarily what you think is true or ideas that appear to you. So please make sure that as you look these over, follow step by step through the rules of logic.